in color. Do you see that? Yeah, it is emitting red light actually. It is emitting red light. Now you can take this home, and this material tells you that gold can show a completely different property that you have not heard of. Have you heard of light emitting gold? No, you haven't heard of. But I can tell you with this example that I can not only make red emitting gold, I can make blue emitting gold, which I have not brought here. I showed it to your minister. I can also make green emitting gold, meaning that I can make this entire spectrum of light, meaning that I can make white light from gold. You know, white light is a mixture of all. So now what I am telling you is that completely different properties can be produced from the very well-known materials, which it will convert carbon monoxide to carbon dioxide. It's an oxidation catalyst. Gold-based catalysts are coming in the market. So you can paint the walls of this room with this kind of material so that carbon monoxide problem is gone. This kind of materials can absorb infrared so that you can paint your walls with this material so that infrared will not get into your room, so that your air conditioner will work with efficiency, so that you can have power saving. If you start looking at, can you increase the light intensity? So if you look at all these, there are infinite possibilities of such materials. I can make a periodic table with this kind of materials. So what I am telling you is that materials at nanoscale have produced a new world. Why am I saying this? The world that you see here is because of matter. You and I are nothing but matter. Matter in microscopic form that you know of. But with nanoscale objects, you can produce a completely different world. And that world is awaiting to be explored. That is what this demonstration has shown. Well, now if you want it, you can have a look at this. But then, there are many other things. So nano is very big, but it is very, very small. So how big is this nano? Well, if you imagine CS Tower is like a meter, let us say, 1 meter tall building. In that, if nanometer is 10 to the power minus 9. It's very difficult to visualize 10 to the power minus 9 in that meter. So I have brought this particular analogy, CS Tower. In CS Tower, imagine a bacterium. Right? If you imagine a bacterium in CS Tower, it is like imagining a nanoparticle in CS Tower. So it's so tiny. And that tiny thing has changed the world. The way we look at chemistry, physics, and material science has changed. If I were to take an analogy, I would take this analogy of quantum. During 1900s, quantum changed our understanding of everything. Today people are using this thing, quantum everywhere, quantum jump, quantum leap and all that, especially politicians say this. Quantum is so tiny, very, very small. If you were to make a quantum step, it's actually no step at all. But quantum is such a tiny thing, we changed everything in 1900. It's so tiny, so tiny. And all of these big things like quantum and nano and all that came at certain points in the history of science. So this kind of a point in the history of science is kind of crossroad. So if you are at a crossroad, you choose whether you go along the path of nano or you go along the path of micro. Or you go along the path of classical mechanics, or you go along the path of quantum mechanics. People chose to go along quantum mechanics. And many interesting things happened. Quantum got us semiconductors. And without transistors and semiconductors,